Hey guys, we're back with another video. This time it's on experimental design. Now it's just like the name implies, it's how you make your experiment. It's how you design it. The first part of this step in experimental design is identifying your variables. A variable is anything that you're going to change in there. Now there's two kinds of variables. The first kind is the independent variable. That's what you actually change. And the dependent variable is what actually gets changed in response to the independent variable. Another way to look at this is the independent variable is what the scientist is going to work with or manipulate. It's the one thing we change. The dependent variable will change in response to that. As a quick example, if you wanted to find out which running shoes were the best, maybe you'd get 5 different brands. That'd be your independent variable. The thing that you change in that is the type of running shoe. The dependent variable would be what you would measure. Maybe you check your running time, or maybe it's a jump height thing. So you would measure it as you wear each pair of shoes and see which one you're fastest on. That would be dependent.
So the dependent variable is what we're testing, so therefore it's probably linked to our hypothesis.
Yeah. Yes, the dependent variable is what we measure and what we're testing.
Yeah. So I always remember it by the one you measure. So we made up an example to show what we're going to show you controlled experiments, and this is an example we came up with. We imagined what Chipotle does when they try to change one of their products. So we made up a scenario. Chipotle wants to reduce the salt content in the rice of their burritos. They make a new recipe of the rice. Everything in the recipe stays the same: lime, cilantro, type of rice, amount of oil in there. The only thing they change is the amount of salt. So in this test, what's the independent variable?
Independent variable in that one would be the amount of salt, because that's what they're changing.
Exactly. And then what do you think there is the dependent variable, Mr. Black?
I'm going to go with the taste, like which one people prefer.
Yeah, so the preference, right?
Yep.
That's what they're measuring. All right, so now what we probably set up in this scenario is what we call a controlled experiment.
So in a controlled experiment, you're going to have multiple groups that you're comparing with each other. And the key thing with this is that everything is exactly the same except for one part that you change. And that one part is your independent variable. So the controlled variables are the things that don't change. So they're everything that stays the same. So in our Chipotle example, that was like the same type of rice, the cilantro, the lime, the salsa. Everything else that was in there is exactly the same. The only thing that gets changed is the independent variable, which is the amount of salt. So controlled variables stay the same across the board for everything. Independent variable, the one thing you're testing. And that allows you to compare. So if something is changed, like the salt, and you get a result, you have a better chance of linking it to that change.
Yeah. So, go ahead.
Okay, so we got a couple groups when you set these up. Now the first group is a control group. That's the one in which you don't change anything. That would be your normal. That would be the one where you're going to compare everything else to. Say, hey, here's what it typically is. In the Chipotle one, it would be the rice with the normal amount of salt, the one they're using right now and selling nationwide. The experimental group, in this case, is the one in which the independent variable gets changed by the scientist, gets changed by the experimenter. In our Chipotle example, it's going to be the rice that has a lesser amount of salt. So the experimental group has the change. That change is a lesser amount of salt.
So why is it important to have that control group, though? Why can't I just change the salt?
You need a control group so you have something to compare it to. Because if I said, hey, my plant grew really tall, and it's the only plant I look at, and it's this tall, if it's a dandelion, that's tall. If it's a sunflower seed or a sunflower, that's not that tall. You need something to compare it to say, is it really a measurable difference?
Okay, cool.
Yeah, in this case, with the Chipotle example, you need to actually be able to compare it to the original recipe to know if it's actually better or not.
Yes.
If they just say they like the reduced salt recipe, you're not really getting an answer of if they prefer it, right?
Yep, makes sense.
So, now, some other things to consider when you're setting up an experiment. First of all, it's always good to have as many trials as possible, and therefore you get as much data as possible. And this is always very reliable. So in this Chipotle example, let's say we only had Mr. Black test out the burritos. Well,
Yes.
Mr. Black, are you feeling very well today? You actually look better than you did yesterday.
A little better, but I still don't feel great. So my taste buds aren't working 100%.
Exactly. So
But
if
I
we
love
on-
burritos.
If we only had Mr. Black test this out, his taste buds aren't, working very well today.
No.
He's not going to be able to tell the difference quite so well. So if you're only using his data, are you going to get the most reliable answer possible? Probably not. Okay? What if Mr. Harkins doesn't even like rice in the first place, and we only have him test out the burritos? Well, I mean, he's going to have kind of weird results because he might even say, I don't like either. So it's always good to get as many as possible. we talked about this before. If we actually did this experiment, we'd probably get at least 100 test subjects.
At least,
least,
yeah.
yeah.
You're going to want as many as you can to get a nice,
The m-
wide survey, because the more data points you get,
Yep, the
the
better.
more you can trust that data.
Yep.
Now, another thing to look out for when you're setting up an experiment is to eliminate what we like to call experimental bias. Now, bias is the preference that a test subject or even the experimenter might have for one thing. So, I want you guys to take a guess. How would I eliminate bias in this example? For example,
Well-
let's say you know you like salt ahead of time,
Mm.
and you might be tempted to, if you knew which burrito it was, pick the one with most salt before you even try tasting them.
I would think you'd have to have some way to make it so that I don't know which burrito was the original type and which one was the experimental
Blindfold.
type.
Yeah.
Ooh, blindfold. But dark that scares me.
But just going to have to deal with it for
All
free
right,
burritos.
all right, free burritos.
Yeah,
I'll do it.
deal with darkness.
So this is how they often do it with taste tests. Not to deviate to another example, but you've probably seen this on commercials. They used to do the Coke and Pepsi challenge.
Yep.
They would not show people which one they were giving them, and then they'd pick one and they go, "Oh, you picked Coke," or "Oh, you
Bing
picked
and
Pepsi."
Google.
Yep.
Yeah, they
Bing
do
and
the same
Google.
thing
Yep.
too.
Yesterday, Bing and Google, they do the same thing on the
So-
commercials.
The key thing is you don't let people see what the two
Yeah.
different things are.
And the reason is, let's say someone likes Coke and they know they like Coke, so they're loyal to that brand. They might be tempted to pick Coke if they knew which one was Coke, no matter what, because they might be admitting they're wrong if they pick Pepsi, right?
There you go.
So you
Yeah.
have to
You
have
gotta
to
watch
blindfold.
bias. Bias is what you want to happen, not what actually happens.
Yep.
So here's a full example, pretty much the culmination of everything we discussed with our Chipotle example. We got 100 test subjects. They're each trying the 2 rice recipes. Everything on each of those burritos, they're each going to have 2 burritos, but everything is exactly the same except for the rice recipe.
Yep.
And even some specifics.
Yep.
Yeah, one thing.
Change one thing.
Yeah, only one thing is different. So maybe they take exactly 3 bites out of each burrito. Okay. We said we're going to blindfold the test subjects.
Yep.
Okay. And after this experiment, Chipotle could maybe use this information to say, hey, maybe we should try this with our recipe, or
Yep.
maybe it was just fine the way.
That's
it
how
was.
these things get done. That's how new items get added to menus all the time for big chain restaurants.
So the key thing when you're making controlled experiments, you want to have only one variable changed. You need something to compare it to. You want to eliminate bias as much as possible, and you want to have a large subject group so you can get good, viable, relatable
Lots of
results.
data points.
All right. I think that's about it for today.
Cool.
Yeah.
Enjoy
Have a
your
good day, guys.
burrito.